All right, problem number 1. You are given $100 and told to spend it all purchasing exactly 100 animals at the pet store. Dogs cost $15, cats cost $1, and mice are 25 cents each. How many of each animal do you have to purchase to equal exactly 100 animals for exactly $100? All right, well, let's define some variables. Let's make them easy to remember too. So let's say D is equal to the number of dogs. All right, and let's say C is, what happened to my pen? C, I don't know what happened to my pen. C is equal to the number of cats, and let's make M equal the number of mice, okay? And then based on these two statements that we have up here, we know that we want to purchase a total of 100 animals, right? So we know that D plus C plus M is equal to 100. All right, and we also know that we want to spend $100, and dogs cost $15, cats cost $1, and mice are 25 cents each. So let's write another equation. We'll say 15D plus C plus, I'm actually going to write 1/4, right? Because that's a quarter of a dollar. 25 cents is a quarter of a dollar. 1/4 M is equal to $100, right? So we have two equations, and that's really all we can formulate with the information that we're given, which could be a problem because usually in order to find 3 unknowns, right, we have to find the number of dogs, number of cats, and the number of mice. You would need 3 equations, right? But let's not get stumped by that. We'll just keep moving forward here and figure out what we know. The way I approach this problem is I saw here that there's a C in this equation and a C in this equation, and if I subtract one and this last equation from the top equation here, I saw that, well, we can eliminate one of the variables anyway. So let's just do that. So if we subtract D from 15D, we get 14D, and of course C minus C, so I'm basically taking this whole equation and subtracting it, okay? C minus C is 0, and 1/4 minus 1 is a negative 3/4 M. And then of course 100 minus 100 is just 0. Okay, so now we have one equation and 2 unknowns. But let's work with this. Let's work with what we've got here. We can rearrange this into 14D is equal to 3/4 M, okay? And I'm actually going to get rid of the fraction here, and I'm going to multiply both sides by 4, okay? And that way this just becomes 1. 4 over 4 becomes 1. And this is, so we have 4 times 14D is equal to 3M, okay? The other piece of information that we do know implicitly in this problem is that we can't sell anybody half a dog or a quarter of a mouse or 2/3 of a cat. I mean, we want these the number of dogs, the number of cats, and the number of mice to be whole numbers. Okay, so no fractions. We're not going to sell you just the tail of a dog. Okay, so so we're going to assume that D and M have to be whole numbers. Okay, so let me scroll down here a little bit, and I'm actually going to use something called the fundamental theorem of okay? And you're probably wondering, oh boy, how am I supposed to know the fundamental theorem of arithmetic? But I bet you know the fundamental theorem of arithmetic. You just don't know this name for it, okay? This looks like a fancy name for something that's really pretty simple. And the fundamental theorem of arithmetic just says that every positive integer except one, meaning the number one, all right, I mean the numeral one, has a unique prime factorization, okay, so has a unique prime factorization, okay? And I'm guessing that most of you have done factor trees, and you I'm guessing you have a sense of this theorem, that there's really only, if you want to factor the number 42, you're only going to have one prime factorization. You're going to have 2, and let's break that up into 21 and 3 and 7. So the only prime factorization is 2 times 3 times 7. Okay, that's just an example. Okay, and there's no other prime factorization of 42. And this theorem is also the reason why the number 1 is defined to be not prime. Okay, so the number 1 is not prime just by definition. And it's important to remember that. And the reason that it's not prime is because if 1 were prime, this theorem wouldn't work very well. Essentially, you could factor any number into well, they would have factors of 1 and 1 times 1 and 1 times 1 times 1 and 1 times 1 times 1 times 1 times 1 times 1, okay? And it just gets messy. So that's why 1 is defined as being not prime, okay? It's not a composite number either, but it's not prime, okay? It has a special place in the realm of integers, okay? So anyway, this fundamental theorem of arithmetic, every positive integer has, except for 1, the number 1, has a unique prime factorization. Okay, forgot the A. Okay, so how can we use this? Let's take this equation that we have here and let's break it up into as many primes as we can. Okay, so 4 is 2 times 2, and then 14 is 2 times 7, and then we can't factor d because we don't really know what it is, right? And then over here we have 3m, and you can't break, 3 is prime, so you can't break that down any further, so we have 3m. And we know that whatever we're dealing with here, these two numbers on the left and the right side of this equation have to be equal, which means they both have to have the same prime factorization. All right? And so let's take a look at this left-hand side. We have 2 times 2 times 7, but we do not have a factor of 3. So d must be 3 or a multiple of 3. Okay? So let's just try 3. If we plug in 3, I guess you could also look at the right-hand side of this equation too. We have 3 and then we have m, and so m has to have factors of 2 times 2 times 2 times 7, which is just 8 times 7, which is 56. So m must be 56 or a multiple of 56? Well, and you can see too that if m really can't be a multiple of 56, right? Because 2 times 56 would be 112, right? And that would we'd go over our number. We'd go over the number of 100, we don't go over 100 animals just with mice, okay? And we don't want to do that because if m is over 100, then the number of cats would have to be negative, and cats don't like to be negative, so we won't do that to them. So, all right. So so now basically we know that D has to be 3, M has to be 56, and then we know there has to be 100 animals. So we have 56 plus 3, that's 59. So we have to have 41 cats. All right, and that is the answer. All right. So when you're dealing with discrete mathematics, that is mathematics that is all in terms of integers, okay, then you can actually solve equations like this sometimes, if you're lucky, because you've got the added fact that all of these variables have to be integers, and then you can use the fundamental theorem of arithmetic. All right? So there you go. That's the answer. 3 dogs, 56 mice, and 41 cats.